Hello, I'm Rebecca the Maths Lady, and in this video we're going to talk about the foundations of subtraction and how it's a little bit more complicated than most adults think it is, and how, unless you think about it, your explanations can confuse children more than help them. We're going to sort all that out today. So here's your quick summary. I'm going to talk about how subtraction is both taking away and counting on. I'll talk about how both of those ideas make sense at the same time and how we help children make sense of it all. I'll also talk about calculation families and how subtraction is linked to addition. And finally, I'll explain why you can't change the order of subtractions as you can change the order of additions. So if you don't need this video, here's a link to the next one. It's helpful to have watched the video on the foundations of addition before you watch this one, but it's not essential. Here's a link to it now if you want it. Okay, let's get started. So if you ask most adults to try and explain what subtraction is, they say it's taking away. You start with a number of objects, you take away some, and you count how many are left. And that's a perfectly reasonable explanation. It works really well in many situations. Let's have a look at it now. If we take a simple subtraction like this one, 9 subtract 2, it's perfectly reasonable to take away 2 of those counters, they're gone, count how many are left, and you get the answer 7. But what happens if we change this calculation slightly? What happens if we make it into, say, 9 subtract 8? 9 subtract 8. How do you do that? Do you actually take away 8 objects and count how many are left? Or do you just kind of know it in a different way? Does it help that the difference is 1? Is that what you're seeing? Or maybe you just think it's a fact that you know, so you don't need to count down one at a time. The answer is 1, and it helps to think about splitting this into 2 parts, an 8 and a 1. The 8 are gone, there's 1 left. What about a calculation like 27 subtract 25? What's the answer and how did you do it? Most people do that by seeing that the difference between the 2 numbers is 2. Therefore, the answer is 2. You could have done it by starting with 27 objects, removing 25 of them, and there would have been 2 left. You could do it by taking away, but it's much easier to do it by finding the difference. It's always true that both methods work for subtraction. Taking away will give you the correct answer. Finding the difference between the 2 numbers will give you the correct answer. But depending on what the numbers are, one method tends to be quicker than the other. If you're subtracting a small number, taking away is generally quicker. But if the 2 numbers in your subtraction are very close to each other, finding the difference is generally quicker. If you had a calculation like 103 subtract 3, you really could do it either way. You could start with 103 and take 3 off, or you could also see that those 2 numbers are 100 apart. Let's just go back to the calculation 27 subtract 25 that we just looked at. It's helpful to draw a diagram where we put 27 in as a total and 25 as one of the parts. What's the other part? Well, it's going to be 2. It's a missing number in the addition to solve the subtraction. And in fact, subtraction is always that. It's always about finding the missing number in an addition that would make the first number. This model for subtraction is called the part-part-whole model. You put the first number in the top and the number you're subtracting in as one of the parts, and you try and find the other part. And you can always do it either by counting on from this part to find the total, how many extra do you need to get this total, or by starting with the total and removing this number of objects and seeing how many are left. So this part-part whole understanding of subtraction underpins both taking away and counting on. It explains why they both work. And it's a useful little diagram for working on with children. So if their calculation is something like 23 subtract 10, we're putting 23 in the top, 10 in the bottom there, and they're trying to find the other part, and you can then ask them what strategy they prefer to use and talk to them about the fact that it's fine to start with 10 and see how many you need to add on to get this, or you can start with 23, remove 10 and see how many are left. And of course the answer is 13. And this diagram also shows you that there are two linked calculations. One is that 10 add 13 is 23, and the other is another subtraction. It's 23 subtract 13 is 10. And people often add the other addition as well into this family, which is 13 add 10 is 23. That's a calculation family. And it's really powerful to think about addition and subtraction together. This diagram is one way of showing it, pretty much a triangle where we've got the two parts and a whole, and addition is about knowing the two parts and finding the whole, and subtraction is about knowing the whole and finding one of the parts. Here's another way of explaining the same idea. Addition is where you start with two amounts and you have to put them together and calculate the total. So in addition, the missing value is the total. But in subtraction, you've got the total and one of the parts, and you need to find the other part. And you can find it either by starting with the total and removing the part that you're given. That's taking away. So start with that and saw this bit off, and you're left with that amount. Or you can start with your part and count on to your total, and that will give you this amount as well. So both taking away the black amount from the blue amount and counting on from the black amount to the blue amount give you the correct answer. This also shows you the calculation family, the two additions, this one and this one, where you're finding this total, and the two subtractions, this one where you're subtracting the black amount to find the red amount, and this one where you're subtracting the red amount to find the black amount. If you're wondering these are Cuisenaire rods, don't worry, I'm not going to get you working with Cuisenaire rods. They're tricky to teach with, but they're sometimes quite nice for explaining a generalisation without particular numbers. Right, let's look at why it's important that you confidently understand that subtraction is both taking away and counting on, or you're going to end up confusing your child. Look at this problem. There are 27 children in the hall. 25 children leave the hall. How many remain? If you look at the structure of the question, is that structure, the children leaving the hall, about taking away or counting on? It's definitely about taking away. You've taken away 25 children from the hall and you're trying to find out how many are left. But most adults would flip to the other model of subtraction and say 25, 26, 27, the answer is 2. And they're getting that answer of 2 by seeing the difference between 25 and 27. So what I'm saying is that adults flip between the two models of subtraction, taking away and counting on all the time without being aware they're doing it. And then in their explanations to children, they do that and they expect children to cope with it. And suddenly you have children who are really, really confused. You say, 27 children in the hall, 25 have left. Well, the answer's 2, and you've done it really quickly, and maybe you haven't even explained it, but they're trying to remove 25 from 27, and they can't do it as quickly, and they're not sure what you're doing, and they're very lost. So the way to solve that is to slow down and say this is a subtraction because we're splitting the children into two groups. We know the size of one of the groups. We want the size of the group that's left in the hall. So it's subtraction. We can do that by taking away or counting on. Which is easier to do here? Is it easier to take away 25 from 27 or to count on from 25 to 27? Either will work, but you do the one that's quicker for you. I know it's faff, but it really makes the difference between having a confused child and a wasted lesson and having a child who's becoming really secure and confident with the foundations of maths. Let's have a look at another one. There were 3 apples in the box. Now there are 34. How many have been added? You might just want to pause the video and think about that one. What's going on here? Why would a child get confused? How could you explain it so that they wouldn't get confused? Well, this is definitely a subtraction of the 34 total in the box now. 3 were already in, and we want to know the other part of the 34. Well, this question is set up as a find the difference question. What's the difference between 3 and 34? But to find the answer, most adults would take away 3 from 34. And that's not what the question says. So you need to be really careful and explain that this is a subtraction because we've got a total of 34 apples. One of the groups was 3 apples that were already in, and we're trying to find the size of the other group. And we can complete that subtraction by taking away 3 from 34 or counting on from 3 to 34. Either is fine because subtraction works either way to find the missing part. Listen to your child's natural method, and then if they're not using the most efficient method, you can explain that to them. The other big idea of subtraction is that you can't just reverse the numbers as you could with addition. If we consider 34 subtract 12, well, that's going to be 22. But if we consider 12 subtract 34, well, once you've taken away 12, you've got none left. So either you can't do it or you're going into a negative situation. You can talk about this with your child, but the answer certainly isn't the same. So just one counterexample proves that you can't reverse them. But children will spend ages reversing them and make loads of mistakes where they reverse them because they've learned they can do that with addition and it becomes natural in calculation. So we have to discuss this deliberately many times with children. You can't just reverse the numbers in subtraction as you could in addition. Let's just look at it, slow down. Can you subtract 8 from 3? What's going to happen? Ask your child, get them to justify it for themselves, that you can't reverse the order of the calculation. If you've never come across the ideas in this video before, they're pretty confusing. So I've created a single page note sheet just to help you reflect on them and make sure that you're okay with them. And that worksheet is posted free for download in all the usual places, which include my Facebook group, which is Expert Primary Maths Teaching, and there's links to other places in the channel description for my Rebecca the Maths Lady YouTube channel. If you've any comments at all about this video or the ideas in it, please add them below on the YouTube channel. I love the discussion. I miss working face to face with people. Please subscribe to the channel and click on the bell and share it with your friends. Let's get all our children really, really thriving with their maths. Thanks so much for sticking with this journey. It will make such a difference to your child. Bye for now.